In this lesson, we will begin to look at dividing monomials. So in this particular case, we have x to the fifth over x to the third. Just so you understand what that really means, is it really means that I have x times x times x times x times x, 5x's on the top, and x times x times x on the bottom. This fraction, if you think about it this way, can be reduced, so I can have 3 of those x's that are in the denominator cancel out with 3 of those x's that are in the numerator, and all I have left are these 2 x's that are in the numerator, which would leave me with x squared, okay? That's the long way to do it. But if you can understand it conceptually that way, it makes it a lot easier to do. The shortcut would be to subtract the exponents. Always take the top number minus the bottom number. So this would leave me with x, oops, sorry. This, if I do it the shortcut way, would be x to the top exponent, which is 5, minus the bottom exponent, which is 3, which of course still gives me x squared. Okay? In the next one now, I've got negative exponents. So if I were to do it the long way, I would want to get those negative exponents switched. And so that x to the negative 6 that's in the bottom, because of this negative exponent, that needs to go up top and become positive. Because this negative exponent is there, that needs to go to the bottom and become positive. So I really have x to the 6th over x to the 3rd, which of course means 6x is on the top, like that, and 3x's on the bottom. And then those 3x's that are on the bottom could cancel with 3x's on the top, and that leaves me with x cubed on the top. Okay, that would be the long way. The shortcut from the get-go would be to subtract those exponents. And so I would take x to the negative 3, the top exponent, subtract the bottom exponent, which would be negative 6. And then, of course, you end up doing boom, boom. And negative 3 plus 6 is x cubed. So either way, you're going to get x cubed. Okay. Here, because this is a negative exponent, it does need to come down. And so I have 1 over x to the 8th times x to the 1st, which then you add those two bottom exponents, and it becomes 1 over x to the 9th. Okay, some of you will do it that way. Others of you will do it where you subtract the exponents. So I have x to the negative 1 on top minus, when you're dividing monomials, you subtract the exponents, minus 8. This becomes x to the negative 9 power, and you can't leave negative exponents in your answer, so you have to make that negative 9 power become happy. Switch its negative attitude to its positive attitude, which means it has to be kicked to the basement to get there. And you need something on top, so of course you're going to put a 1. Okay? Either way you choose to do it is fine. All right, this is pretty similar, except for now we've got some coefficients that we're dealing with. So we've got that the fraction 3 over 4 in the front. So I am going to simply think of this part right here as a fraction, 3/4. And I can't do anything with it. It is just simply 3/4. And then I will take y to the top exponent, which is 2, minus the bottom exponent, which is 5. Okay? Which of course becomes 3/4 y to the negative 3. Okay, now this y to the negative 3 is really over 1 right now. And because you have a negative exponent, this exponent needs to go to the bottom. And so what this will end up looking like is 3 over 4, and then that y to the cubed is going to go to the bottom too. So this is what your answer should look like. Some of you will do it that way. Some of you will realize what I really have is 3y squared, which is like that, over 4y to the 5th, which is like that. And then you'll go, ooh, I can cancel 2 of those with 2 of those. That leaves me with no y's on the top. And I will have 4y cubed on the bottom. And by the way, if this is kind of the train of thought that you would like to use this second method, you don't need to write out all those y's for me. You can just cancel the y's where you see y's. But make sure that before you cancel them, you have all your positive exponents, all your negative exponents switched to positive ones, and then start canceling. Okay? So let's make, if we were to do this kind of the longer way, I would take this negative right here, I would move it downstairs so that it became happy. I know the 8 is negative, but it is not a negative exponent, so leave it up top as negative 8. Don't switch it to the bottom and make it positive because it's not the exponent that's negative, okay? Then on the bottom, I have the x to the 4th and that x to the 8th that I'm going to move down, okay? And then I have negative 8 on the bottom. I would add my two exponents and become x to the 12th. So 4 plus 8 becomes x to the 12th. The other way you could think about this is you have your negative 8 right here, and then I would have x to the negative 8 minus my bottom exponent, which is 4, which of course becomes negative 8 x to the negative 12th. And then this would need to come to the bottom so that it can become happy. And you can get the same answer either way. Whichever method works for you, that's great. All right, here we go. Again, you're going to think of this negative 2 over 6 as a fraction, okay? So negative 2 over 6 would reduce to negative 1/3. Okay? Then, if you want to think of the x's here as having two x's on top and 1, 2, 3, 4, 5, 6 of them on the bottom, of course you can cancel two of those with two of those. You still have 4 x's left that happen to be in the denominator. So I would have x to the 4th down here. Okay? Then with your y's, I have 1y down here and I have 7 up here. And of course I would cancel that 1y with one of those. And I still have these 6 y's left, but they are in the numerator. Okay, and so my answer would look like that. You really don't even need the 1 in there. To clean this up, I would actually write negative y to the 6th over 3x to the 4th. Okay, of course the other thing you can do is subtract or reduce the negative 2 6 and get negative 1/3. And then do x to the 2 minus 6 and y to the 7 minus 1, which of course becomes negative 1/3 x to the negative 4, y to the 6th, and then that one needs to go down. Okay, so however you want to think about it, I don't care, but just make sure you follow whatever works for you. Okay, here we are raising a fraction to a power. So just remember that when you're raising a fraction to a power, you're really going to take the numerator and raise it to a power, and the denominator and raise it to that same power. Okay, so don't get freaked out about fractions. Then p to the negative 3 to the 8th power. When you're raising a power to a power, you multiply. So I would have p to the negative 24. On the bottom, q to the 3 times 8 would also be q to the positive 24. And then this p has a negative exponent on it, and so it needs to come downstairs. And so this would become q, and actually I should list the p first so that we have it in alphabetical order. This would become p to the positive 24 and q to the positive 24, and then a 1 on the top because I need a numerator. When you have a negative exponent, and I know we've talked about these, but they always give people trouble, so we're going to kind of continue talking about them. Again, when you're raising something to a power and it's a fraction, you can think of taking the numerator to that power and then the denominator to that power. Okay, now, in both cases, I have negative exponents right there. Okay, so this 3p squared needs to go down, and this q squared needs to come up. Okay, so on the top I will have q squared squared, and now that q squared became positive, and then I will have 3p squared squared. Okay, on the top then, q squared squared, I will multiply those two exponents and make that be q to the 2 times 2, or q to the 4th. On the bottom, don't forget to square this 3. So 3 squared is 9. And then q to the 2 times 2 would be q to the 4th. p to the fourth, not q, sorry. So it should look like that. All right. This is the only exponent that is negative. So that is the only quantity that is going to go downstairs. So this is going to stay downstairs, 2r to the third squared. But that numerator has to come to the bottom so that that outside exponent becomes positive. Notice this exponent doesn't change when you bring it to the bottom. Only that outside exponent changes. Okay? That leaves me with 1 on the top. Then right here, 2 squared is 4. R to the 3 times 2 would be r to the 6th times. Okay, right here, 5 squared is 25. R to the negative 2 times 2 is r to the negative 4th. Okay. Then you can approach this a couple of different ways as well. Some people will choose to go, ooh, I can add those exponents right away and make 6 plus negative 4, which makes r squared, and it's going to stay right where it is. Some people will go, ooh, this one is negative, so I better move it to the top. And if I move it to the top, I will have r to the 4th. Then on the bottom, I will have 4 times 25, and 4 times 25 is 100. And then I still have this r to the 6th down here that's positive. Okay? And then people will go, ooh, this is like having 1, 2, 3, 4 r's, and this is 1, 2, 3, 4, 5, 6 r's. So I can cancel 4 of those with 4 of those. And then I will have on the bottom 100 r squared and a 1 on the top. All right, this is just kind of a fun one. It's actually technically not even mathematically correct because I have 2 different L's in there, but we're going to go for it. Okay, so here we go. If I think about canceling these, d squared over d cubed, I have one more d in the bottom than I do in the numerator, so this is going to be a d. If I cancel this, a cubed over a squared, I will have an a in the numerator. If I cancel this, I will have one more L in the numerator. I have 4 in the numerator, 3 in the denominator. I have 1 left in the numerator. Here, 5 on top, 6 on the bottom. They can cancel out, and I can have 1 O left on the bottom. Here, 7 on top, 6 on the bottom. I can cancel them out and leave 1 more on top. Here, 1 on top, 2 on the bottom. So that leaves me with an N on the bottom. And here, 3 on top, 4 on the bottom. That leaves me with 1 E left on the bottom. All done. Technically, if this were mathematically correct, this should say A L squared because I should add this one and that one over D-O-N-E. But we just try to make this fun. So there you go.